Courtney has done some work on this in the past, and I expect to see more of it coming. We'll be presenting about electrochromic glass. So, Reneesh, please take it away.
Good morning, Samir and Chad worked on looking at electrochromic glass a couple of months ago. So I'm just going to be kind of giving a small presentation on it, what it is, and why we might look into it. So first of all, it's a smart glass, and smart glass is basically anything that has the capability to be able to adjust tint, heat, and noise blocking, be able to display images and videos, which we'll see in a little bit with Kevin's project with National Geographic, and then some solar power collection. So there's two types of smart glass. There's the passive and the active. We're going to look at the active side with the electrochromic, which we're going to look at further down, and polymer and the suspended particle device. Basically all works similarly. Polymer and the PD and the SPD have randomly aligned electrode parts, and then once the voltage hits, it kind of aligns itself to let light pass through. Polymer has the fastest switch speed, while electrochromic has the slowest, but polymer, the PD one has a very low range of options, while this SPD has a bit more variable and dimming options, as well as the electrochromic. So what is electrochromic glass? It's referred to as a smart glass, just like I said earlier. And it's essentially a glass that can change its light transmission properties when an electrical voltage is applied. And it requires a thin film or coating which can undergo a reversible chemical reaction when triggered by electricity. So a lot of chemistry. And as I mentioned earlier, the tints and display stuff. So how does it work? So there's multiple layers that we should look in. So the outer glass, that's self-explanatory. Then there's the transparent conductive coating made of indium tin oxide or something similar that will conduct electricity while allowing light to pass through, which will let the tint adjustment happen. And the electrochromic layer is the thin layer made of tungsten oxide that changes color when ions move into or out of it. The ion conductor facilitates the movement when glass is in a clear state. So a quick thing from before is that the polymer dispersed and the suspended particle dispersed requires constant power, while electrochromic doesn't necessarily need it. So what's the impact on us? So for integration into IGUs used in double or triple glazed system and the radial layer in the central lamination, and you probably have a little bit more thicker spacer to accommodate for wire to tint the glass and the video functions. There's two main manufacturers, Sage Glass and Viewing, although now Viewing kind of got out of it and it's now bought by Saint-Gobain, which is also backing Sage Glass. And then the electrical wiring has the dual bus bar and then how it's concealed, and the structural, we'll look at the thickness, some edge sealing, and thermal expansion on it. So just a quick note on Sage Glass and Viewing. They're both based in America, while Sage Glass has a lot more coverage outside of US and inside of US too, compared to the Viewing, which only had projects that I saw in US.
You said Viewing was owned by Saint-Gobain?
Yeah, so they used to be by themselves, and then I saw, like, while I was researching earlier, that they got bankrupt. They filed for bankruptcy in 2024.
And still ahead of their time.
The other one that was used for Kevin's project.
Sage Glass is backed by,
Yeah, Sage Glass was backed by Saint-Gobain. They originally been backed by Saint-Gobain. I think once they filed for bankruptcy, then Saint-Gobain kind of bought them over.
somebody is grabbing the market,
Yep.
cornering the market.
I'm looking for some stock.
Yes.
I'm excited. It's public domain.
So for structural, we just mainly look at the thickness and the wind load. Thickness, it's very small weight add that can be negligible. And then the wind load is basically just for the deflection of the glass, that if it deflects over a 0.75 to 1 inch, is acceptable, but if it goes over that, then you'll have trouble with the actual functionality of electrochromic layers and stuff like that. So that would be an issue, and the glass itself being an issue, of course. And then the thermal stress glass, there's a video layer that could add heat to it. So it's like 1 to 2 watt per feet squared. Possible some thermal modeling need to be done, maybe not. And then this is very sensitive, so the sealing is to be very important. Poor sealing can degrade performance, so you'll need robust edge details to protect the system over slice span. Sage Glass in its technical data sheet had a 3/4 inch black obscuration band, which applied near the edge of the glass to further protect the sealing. So here's a little quick insight on the Sage Glass manual on the configuration. So it's similar to what I showed you in, I think, like the beginning of the slides, how it works. And it has some of these layers, and you see the gray here is the electrochromic coating that does the tinting and all that stuff that makes it look fancy. And then there's some thickness options. So the clear option has a lot more options to choose from, but if you go into any coloring and stuff, then you only use a 1/4 inch. Some more basic details on the IGU makeups and stuff from the Sage Glass. This is just a quick diagram of what's going on inside. Bus bar, coating used to transfer the electric charge into the coating, and then the pigtail kind of connects the frame cable, which leads to the system. And then here's a quick chart from viewing on deflection allowable based on the thickness and a 5x10 IGU. So as you can see, there's the allowable. If it's within that 1 inch margin, then you're good.
Really?
Yeah.
Yeah.
Glass back.
Yep. So they're not responsible for that, so I guess MEPLA would be the use if you're gonna do the engineering on it. And then you can also reach out to them, but I don't know if that's possible anymore with them being bankrupt. And I guess you would contact ST Saint-Gobain about this, yeah. So there's the visual light transmittance, it's the tinting. The video mode reduces clarity, the SGC window 9 2.5 clear. And so the electrochromic, like I said earlier, it has the slowest switch speed, takes about 1 to 10 minutes, while like the PD and the SPD is like milliseconds and boom. So here's a small case study from Ewing. Just mainly for business analysis look at. So there's a DFW airport gates that was analyzed where an adjacent gate was looked at that didn't have the electrochromic glass, and it had the surface temperatures to be at like 90 degrees during the summer, while the one that had the electrochromic glass was like 15 degrees cooler. So you'll see more people lingering in that gate, meaning that if there's like restaurants and other things, if they're waiting there longer, they're gonna get hungry and possibly start looking at eating out and increasing revenue. So benefits, the energy control and visual communication, and it also meets ASHRAE 90.1, which is just an energy efficiency code. But there are challenges in the sense that it's a lot more expensive to implement compared to like a regular glass. So the standard glass is $3 to $15, and the laminated glass is the one that would go up to like $60 per foot squared. And then this is the project from Kevin that was by Bellwether. The north face had the electrochromic glass, and like I said earlier, it has the visual transmission, so like image display, video display, and we can kind of see that in this video.
Which company is the manufacturer of that?
This one is Gauzy.
Is what?
Gauzy. It's Iranian based, it's Middle East.
There's actually 5 other companies and Gauzy's listed number 2, specializing in liquid crystal and SPD.
Yeah, so the polymer dispersed and the SPD is what Gauzy is specialized. I think they do electrochromic based stuff too, but their main focus was on the polymer dispersed and the suspended particles.
Which I said those, Brian said the lights cost. I can't remember.
Well, I think each
Maybe the
light is
side.
20 feet tall.
It's across the whole front of the building, so that whale's gonna be full size swimming across the building.
Can you imagine the risk of lawn mowing in that area?
$30 a square foot.
Where they see line.
Yeah,
So 140 times that?
The glass makeup was about 34 feet, 33 and a half feet by 80, almost 85 and a half feet from.
Like 20 grand.
So I have some cost analysis based on what I was looking at earlier with, it can go from almost 300K to almost 450K. Not
That's just the price of the glass.
So yeah, then you gotta add into all the other stuff. And that's gonna ramp up the price a lot.
I really like the idea of this type of product and using glass as like solar panels on buildings.
Yeah.
But it also freaks me out because of an article I read a couple of years ago. So there was a project, I think it was around New York City, and you know how you have those buttons that you press for the ADA and the door automatically opens?
Mhm.
Well, one of the wires over time got frayed. So now it was able to arc to the aluminum. And it electrified the whole curtain wall. And nobody knew it because nobody was touching the curtain wall on a daily basis. And nobody knows how long it happened until somebody leaned up against the curtain wall and got the shock of a life.
Wow.
And they had to figure out where was it getting electrified at?
So if you're going to the National Geographic after there.
I was thinking exactly as Kyle said, and I was checking it out on internet, and it's called, I don't know how to say this in English, Javier. It's an anodo y cátodo, like chemistry.
Yeah,
because
anodic and cathodic reaction.
when there's electricity and aluminum and steel are connected, the steel becomes the cathode and the aluminum becomes and start corrosion in here. So it will disappear in some time. So it's really, really dangerous. So the maintenance in there should be really required, I think.
Yeah.
Otherwise, the aluminum will be
It was all steel.
Steel.
better.
And the article I read, the conclusion, and it was a really good conclusion, was how a 2-foot piece of plastic, those little corrugated things you could put the wires in, could have saved hundreds of thousands of dollars in a lawsuit. So the recommendation was when you're using wires in aluminum curtain walls or storefronts, make sure they're coated not just with their normal insulation, but put them in something that also protects it.
Of course.
I went around for the next month not touching any curtain walls anywhere.
Lessons learned there.
But the guy who touched it got hospitalized, so that must have been a shock. I didn't want to feel that.
Did he become electro?
I don't know. He must have been grounded somehow. So I would assume if you had rubberized shoes on, then I don't know.
Well, I think they only ever run low voltage to anything electric on the doors and all that sort of stuff.
Could be.
And this is kind of outside of our wheelhouse, but for whatever reason, I never thought of aluminum as a high conductor of electricity.
My
Also-
house has aluminum wiring in it.
Yeah,
They don't use it anymore that I'm aware of.
yeah.
They get the electric from the pole to your house. The main wire that Evergy has
Is it aluminum?
that goes to your panel box. It's typically aluminum these days.
Oh, I thought it was copper.
Yes, it's copper.
Not in the United States.
you have more on this, Reneesh?
I had like one more slide, that's it.
Learn to watch out for.
Okay.
Structure.
Yeah, I think this was the last one. And so with Kevin's go by, we looked at it, and then although the electrochromic glass adds slight weight, it's negligible, and then the sizing was not really considered, and so it was thinner or conservatively. And no thermal analysis was performed.
Watch out on this, because luckily when I got involved doing the prelim,
Mhm.
no other cued me into like, this is electrochromic glass and weird. watch out on drawings, like not all clients do that. And because of the electrochromic glass, it was weird. Remember, we had to completely ignore it.
Yep.
So essentially we had two pieces of 5/16 glass that's laminated together. If, we would have just went through and not been given a heads up, I probably would have just assumed, oh, PVB, or asked some stuff about the inner layers. And they gave us values that were similar to PVB, if I remember right. But basically the consultant and everybody agreed like, hey, we just need to completely ignore it. So we just treated it like two pieces of monolithic glass not glued together. Just watch out for that.
And I guess can the ones that have worked on this type of glass, since window glass design is not recommended, not supported, how would one go about running wind load check on these pieces?
We did it in MEPLA.
MEPLA, but for the inner layer, is there any?
So we had two layers of glass next to each other, but not glued.
So they could slide against each other.
Yeah.
Okay, the shear modulus was like 0, basically.
How'd you do that though? Cause doesn't MEPLA make you have to have an odd number of layers?
I think we did a airspace.
I'd have to open it up.
You just completely ignore it or something.
I'd have to look at it. We have
It
it.
was probably more than enough for whatever wind load that it receives anyway.
Yeah, it was either airspace or ignored it. I can't remember.
If the
Don't
glasses
use
are
MEPLA
touched,
6.
you could do it just not taking account the interlayer, just a section of glass and a section of glass, and that won't necessarily have to have a shear number or interlayer in between them. Just two layers of glass.
I think we're
And
gonna
like-
see a lot more of this kind of work. In every futuristic movie, picture, this is what's there.
Yeah.
You can buy an LG TV right now that's clear with the smart glass.
That is a good Christmas holiday party gift.
So just on the electrochromatic, we were driving down past Overland Park and it was at night and we saw beautiful buildings that we designed up at the top.
City Place.
Was that, it was what?
City Place.
City Place, okay. Was that electrochromatic or was it just signs?
screen behind.
It was screens, okay.
It's not quite as
That's,
cool, but.
Yeah, I was thinking that the spear was also something similar to it, but it's just like a LED. Yeah.
It's LED, yeah. Okay.
I thought it would have been using these stuff, but it didn't.
So are there any big notable projects that have the electrochromatic?
There's some on the Walmart campus. We did it, was it the hotel, I think? I can't remember now, but we used, I think it was viewing,
Are you talking about the,
but yeah, there's a lot of prep. And they had to test the glass when it came off the line. They had to test it when it got to our shop. They had to test it when it got down to Arkansas. And then they had to test it whenever it got installed. And we're having to run wiring through cop joints and all sorts of crazy stuff to get everything to work.
You're transporting material that's so sensitive. You want to make sure that when it's installed, it still works.
We had to
What is
unbox it,
downtown,
rebox it.
does Dubai or Saudi have anything with the electrochromatic that you recall?
Yeah.
Do some of those.
Centennial Yards?
These are some of the case studies for that from Sage Glass that they used the electrochromic glass and stuff.
That project got canceled.
I don't think like all the electrochromic glass stuff necessarily has the radio transmission like we saw with the National Geographic. Most of it's used as like a tinting mechanism to save energy bills, not necessarily for the cooler aspect of playing elephants and aquarium whales.
Can you check where is the biggest, like where in the world is the biggest glass that they have?
Germany had some. That's what they made.
Remember those panels on that Apple headquarters or something where they had like the.
Apple, something Apple would do one day.
Do you remember a project in the fringe of Chicago? And it had some graphics up on the curtain wall? Do you remember that? It's been a while. I don't know if that was electrochromatic or if it was something, I'll have to look that up.
1.6 million.
Office square foot development. Cool.
Cool. Yeah, we expect to see some of this come our way again, and Kevin and Gorney would help us on as it go by on their National Geographic project.